Thanks, Andrew, and welcome everyone. I'm sat here at home, as most people in the UK are doing at the moment. Quite a bizarre environment we're living in right now, and as I look out of the window, normally I would see lots and lots of aircraft flying into Heathrow, and I see nothing in the sky at all. We are living in bizarre times, and I think, as Andrew said, the world will change as we get out of all of this down the track. What I wanted to do today was, I guess, share some of my experiences that I've had in my career to date. The career that sort of started in research, worked in CSIRO for about 7.5 years, and then moved to IMDEX as a kind of product manager, technology specialist. I guess share some of my experiences in what I've seen when you try and bring new technology or disruptive systems into environments like a mine site or like an exploration environment, and really more touch on not so much the technology aspect, but what does it mean for people, and some of my observations around some of those challenges you might face with people and bringing that technology to bear. I'm not an expert in this, so this really is just me talking from experience. I guess one of the things that IMDEX is been looking at quite long and hard is the fact that we have in the industry sort of a systemic challenge, I guess, a challenge around time. And if we think about the drilling cycle, be it exploration or mining, blast hole drilling, that drilling cycle is the ability to drill a hole, the ability to drill that hole to take a sample, to measure something in that sample, to interpret that data and make a decision. That cycle is embedded in everything we do day in, day out. And the bottom line is that cycle really takes too long. We always want to get that decision made a lot quicker than we can right now. And there's a whole series of pinch points there in that cycle, be it the technology of drilling, the way we take the sample, how we measure something in that sample, and the ability to interpret that data and make that decision. And that drilling cycle is also a risk decision cycle. So really that cycle is about de-risking what we're doing. And again, like I said, it doesn't matter whether that's greenfields, early stage exploration, or in the sort of resource drill out or blast hole environment. That cycle is too long. So one of the things we're seeing is a real drive to kind of try and address the technology pieces required to shorten that cycle. And I guess one of the things that we in IMDEX have been thinking about is really that ultimately what we're asking for, or what we really want as an industry, is rock knowledge. And what do I mean by rock knowledge? It's really a understanding for that sample that we take, that sort of representative piece of the ground we're drilling through. We want to know something about the grade or the geochemistry. We want to know something about the texture. We want to know something about the mineralogy, and we want to know the location in 3D space of where that sample came from. And if you can actually collect all four of those components, build that rock knowledge, that knowledge about that piece of ground, that's going to be, those properties will be used in your interpretation in every aspect of everything we do. So from exploration, am I in a deposit, am I not in a deposit, all the way through to how do I process this bit of rock? How hard is it? How easy is it going to be to extract the metal of choice? And I guess for the geoscientists in the industry, what we really want to do is be able to deliver that rock knowledge as information products. So what do I mean by that? It's really about delivering not just data streams, but information to the geologist or the decision maker in near real time. So that's about shortening that cycle. And to do that, it's going to be a combination of bringing together technology, bringing together the data flows, the workflows that wrap it all up around the analytics as well. So turning multiple data streams into something that we can look at as a geologist and make a decision. Here's just a quick example here in this plot here. We've got some lithology, some alteration logs, but what you've got here is portable XRF chemistry. You've got a gamma trace here in red. You've got some gold assays here, and then we've taken all of these data streams into iGas, and we've generated some self-organizing map classifications here. So this is about taking multiple raw data streams and generating a classification, a domained classification, if you like, that the geologist can then make an assessment on what's going on. So here we're going, here's an arsenopyrite dominant zone. These are zones that are not. And so suddenly you've got an ability to make a really quick decision about whether that piece of ore is going to one place or another, or in an exploration context, whether that is useful ore or not. So it's about wrapping all of this together to give us these information products to support that decision-making process. And one of the really critical things that's happened, I guess, is it's about getting the data or the information products where you need it as well. It's moving away from that chain of data transfer that we've seen in the industry to trying to get into kind of a seamless data transfer environment. And here's just an example for an XRF, for a portable XRF, where traditional method of transferring that data via some USB key to a computer, transferring that data then to your database administrator somewhere, input it into the database, store it, and then someone can come along, extract that data, look at it, and 6 months down the track, they realize that something was done wrong or that data wasn't collected correctly. Moving to a place where we can actually seamlessly transfer that data through secure chain of custody, through APIs, through systems, and present the data and the information products to that person where they need it. So IMDEX have our IMDEX hub system, which connects our technologies and allows that data to transfer through to third-party databases or to pieces of software like iGas for data analysis. And no one's touching this data. This data is moving without being touched at all in a secure chain of custody. And so you can see that in this top workflow, there's a lot of touch points by people. Whereas in this bottom workflow, we simplify a lot of that and actually take a lot of the burden of the time that occurs in that top workflow away from those people that get bogged down in that kind of workflow. So ultimately, trying to deliver the information to this person here looking at the rock, and you're trying to do that quickly, but you're trying to take a lot of their burden away from them about how they get that information. So the geologist of the future might look a little bit like this. This is a sort of a cartoon picture that we've been painting recently. And here's a sort of a very idealistic view. You can see there a sort of a drill out project and a mining project there on the right. And that geologist sat there with this kind of streams of data coming in that environment, information products, that ability to make decisions, shorten those cycles and increase that productivity. But that picture there that I'm painting clearly is a very different picture to the kind of perception that people might have as they've gone to university and wanting to kind of learn about rocks, learn about the geology, geoscience. So really, if you think about the people on the ground, it's their perception. I mean, I love this. I think Michelle Carey showed this first in a talk, but it really is about perception. You know, how do you tell that geologist, you know, who has this perception, society have a perception of what a geologist is? Yeah, certainly the bottom right-hand quadrant is pretty well, most geologists I know do a lot of that. But yeah, that person's gone to university, they've learnt those skills, and now we're asking them to do their job differently. We're not necessarily saying don't be a geoscientist. We're saying you're gonna receive your supporting information in a different way, and you might have to have some different skills. So you can go and solve the technology piece of this and bring all of those things to bear. But ultimately, all of this is a success only if those people in those roles buy into and work with the new systems. And we have to deal with some of these perception issues. Now, I love this phrase. I heard this the other day from one of my colleagues. And I think it really encapsulates some of the things we have to think about when you walk onto a mine site or an exploration program and you're trying to bring new systems or technology to bear. And it's really about what are those people working in that environment? How do they see themselves within that environment? So a traveler came across 3 men working. He asked the first man what he was doing, and the man said he was laying bricks. He asked the second man the same question, and he said he was putting up a wall. And when he got to the third man and asked him what he was doing, he said he was building a cathedral. And really what we're saying here is is that person going to work just to do the job? Is that person going to work to kind of work in the department? Or is that person going to work because they understand the value of what they're doing holistically for that company, the end product? And those individuals all have their place in that environment, but their adoption, their ability to adopt or work with these new systems and technologies is going to be very different. So you have to treat these people very differently. And one of the things I found really important when you're taking very disruptive technologies into these environments is there's no shortage of just stopping and listening to what people say to you and working around those different personalities. It's a very hands-on process at that very early stage. And really understanding where we are in that stage as well. And I guess that brings us through to how do we really understand who our people are in our organizations? So many of you, some of you at least, will have read Crossing the Chasm by Geoffrey Moore. So the Chasm, or the Crossing the Chasm book, was a way of addressing go-to-market strategies for disruptive technology startups. So this is something that came out of the sort of Silicon Valley boom in the early 2000s, and a recognition of how startup companies really get these new disruptive technologies to market and how they address the problems of getting to market. And what they realized was that the market can almost be classified into a set of sort of different classifications, if you like. So the early market, made up of innovators and early adopters, they're going to take the technology pretty quickly. The early majority are the bulk of your market, but they're not going to take on that technology until it's been validated and justified by those early adopters. So this is a sort of a market assessment, but it's also a really useful assessment for the range of people and personalities that we have in a particular company or a particular site environment. So if you walk onto a mine site, what you will find is there will be innovators and there will be early adopters, and then there'll be the early majority, the late majority, and the laggards, and all of those people exist. And so not only is it a market segmentation, but it's also a people segmentation within an environment. And really trying to work out how you make those different groups work together to bring a disruptive technology through to fruition is really important. The innovators here, they will take on a technology, whatever. Totally happy to take a technology if it's buggy, if it needs a lot of work, a lot of shoehorning, some real manipulation. So, Andrew would be a good example of an innovator. He sat there with 4 devices right now, doing a range of things at once. The early adopters are going to be happy to take that technology on once you've started to prove that it will fit into their workflows. Now, they'll take it on early, but they need to see that the value is there while it plugs into the workflows, the full end-to-end workflows. Like I said, the early majority are not going to buy into that technology until they can see that early adopters out there have proved the technology works end to end without problems. And so I think you can all recognize that those individuals will exist in all of our organizations. And I think it's really critical when you're trying to bring disruptive technology in that you identify those individuals and work with them, and having those critical innovators and early adopters within the organizations and their abilities to communicate back to their own organization and be your voice on the ground as you're bringing this technology in is absolutely critical here. It's a really nice frame of those people. So I absolutely advise anyone that hasn't read the book, go and read the book. There's some really interesting insights within that book. It's been updated recently, so it's a good read. So a couple of examples from my side of the kind of things we've done and some of the experiences. I guess something I've been involved in for many, many, many years is solving the challenge of how to, uh, I guess, enhance the use of portable XRF. So portable XRF is a really interesting example of a technology introduced to our market in about 2005, 2006. Really took 10 years to really ramp up its use, and is now pretty well accepted as a key technology in most parts of our industry for generating the ability to generate data for rapid decision making. Now, the problem with portable XRF is it's not so much the hardware. The hardware has advanced and it's become incredibly robust. It's very, very reliable now, and the quality of data you get from it is extremely good. So the hardware and the hardware manufacturers have done a really good job of that. But where the problems exist with portable XRF is in the way that we manage the data, the way that the user is using that device, and then the quality of the sample presented to the portable XRF. Now, the quality of the data from these devices is now so good that it's actually the quality of the sample that is now the inhibiting factor. So we looked at this problem, and we've been trying to address this problem for a long time of how do we deliver the value of real-time assay at the drill site or close to the drill site near real time. One of the projects I was involved in very early on, and Andrew was heavily involved in this, the back end of the Deep Exploration Technology CRC, was the Lab at Rig project. Lab at Rig was about the ability to assay curve cuttings from diamond drilling to give us extremely quick assay results at the time of diamond drilling. And we worked on that as part of a CRC, a collaboration between academia and industry there at the time, and then took that out and worked really closely with Barrick at the time to try a proof of concept. And here's an example of a manual version of a Lab at Rig working on a diamond drill program. This one's in Nevada with Barrick a few years back. And when we went and did that with the buy-in of that company, that whole process, that proof of concept was really run with a lot of learnings that came out of that. So at the time, I guess, we had Andrew there in Barrick as that innovator. He just wanted this. He wanted this to work. He wanted it to happen. And a whole bunch of people got behind this, and we did this proof of concept. Now, there's a fair cost to kind of doing something like this, a lot of logistics time, and a lot of support from everyone involved. The team on the ground, I guess, quite rightly, were a bit suspect about it. They didn't think that this was going to work. They didn't think the data would be high enough quality. And it was a really good example of just having to go and do something with the support of management. You take the burden off them. There's no burden on that team on the ground. But the moment that we stood in the courtyard and we were looking at near real-time Lab at Rig data, and some of those geologists were then seeing those same features and the geochemistry of those same features in core that had just been drilled, suddenly then they buy into what the workflow and the systems are. Now, there's a fair bit of work to do to go from a proof of concept like that into something that is commercially viable and can be deployed, and that bubbles along in the background. But I guess we learned so much about that, and we learned so much about the problems of trying to deliver near real-time assay information, that what we've gone and done, I guess, is to bring together a sort of a simplistic modular Lab at Rig system, if you like, to market. And here we're talking about bits of equipment that arrive in Pelican cases. So some sample prep equipment, some software, and a cloud-based system. And but by doing this, we're starting to kind of really put a very disruptive workflow in place with the industry that does cause a fair bit of change. There's a fair bit of change to the way that people's systems work and that kind of stuff. And if you look at this whole picture here, you've got your sort of sample prep hardware here, you've got software. You can see that there's a whole bunch of different components here that need to work together. Some of them are literally just hardware. So these are things that smash and grind and pulp and press bits of rock. There's not much in the way of kind of fancy data analytics or anything on these. There's some LED lights. I was allowed to have those, but that's a very different kind of environment or interface to the piece of software here, for instance, or the sensing technology, which is portable XRF, or the way that we might use the data into analytics processes like iGas. So here, it's not just about individual products, it's about delivering an ecosystem of hardware and software. And the value only comes when you slave it all together. And so you can see that there are many touch points there and lots of different people that need to get involved in that. So it's quite a complex process to bring something like this to market. And you can see how those key innovators, early adopters in a company, those people that can touch all of those places and help the right people to get on board with this become really, really important. Because at the end of the day, it's not just about delivering the data, as I said, it's about delivering the information products to support a decision. And that's where the value is. The value is not the fact that you can crush a piece of rock. The value is the fact that you can plot a very high quality portable XRF analysis onto a classification plot. You can maybe classify your data downhole very, very rapidly, something like that, and make decisions about what's happening in your drilling. These examples here are actually data from some drilling that was done in South Australia, where we've used self-organizing map classifications on the geochemistry from portable XRF to then map in classifications from future drilling so that we know roughly where these different units are relative to each other. And you can do that in near real time. And I guess to take that further here, we've actually taken those downhole plots and put a thing called a wavelet tessellation. So wavelet tessellation is a new feature in iGas. This was another commercial product from the DET CRC. And it's a way of taking that downhole trace and actually classifying it into different features at different scales. What does that mean for the geologist? Well, suddenly there's a picture there that they can match up to their core that they're looking at. So they can see where those key boundaries are at the very first moment they lay that core out or very early on in the process. It supports them to be a geologist. It supports that logging process. And I think that's really important, is that at the end of the day, we've got geoscience knowledge in the head of that person making a decision, but they need to be supported by the information products that take in the numerical, the technology, the data and software systems, and the visualization. So there's a whole bunch of new skills here that sit in this domain from this new disruptive technology. And traditionally, this person might have been exposed to some of this, but I think going forward, we're going to need more and more of these skills in understanding how this works, not necessarily every detail of the mathematics, but the understanding of how this all works to support this person's geoscience knowledge. One of the consequences of getting this correct and getting the data flowing correctly is that we get rid of some of the burden that this individual faces at the moment around things like database administration, managing file systems, bolted together processes that may or may not work well, QA, QC, the list goes on. There's a whole bunch of work that that person might be doing right now that if we get the data flowing correctly, they don't have to do, and then they can now use it to make decisions on the basis of information products. So just another example, and we've got people doing this around the place. So this is an example of a data information ecosystem. So this is our Easy Gamma product. So this is a product that is a natural gamma logging probe that can be used or deployed by the driller. So it doesn't use uphole comms, it uses nothing complicated, it's a memory-based tool, and you go and collect natural gamma logging data. That can then be collected, transmitted automatically to our IMDEX hub system, sucked into iGas. The wiggly line can have a wavelet tessellation done. That wavelet tessellation picks out a bunch of the key boundaries. They're delivered on a tablet at the logging site, and that person uses those key boundaries to help and aid what they do in terms of logging. So this person, this geologist, is not out there deploying the probe. This process here is done within a piece of software that's made quite easy to do. But at the end of the day, they've got boundaries here that they can then see within their core and speed up, improve, and support them to do the logging which is the important bit that requires their geoscience knowledge. And you can also see, I guess, from this diagram that it does also require us to work alongside it to just deploy that one product. You need to then obviously train the geologist to do some aspects of this. You need to train the drillers to do other aspects of this. So there are, again, multiple touch points, and this all has to work together in a seamless way. So we're certainly getting to the point where we've now got technology available and data ecosystems that are becoming more and more available that really allows us to make these near real-time decisions. And this is a slide that I've been putting up for a number of years now, of really saying that if you can make these real-time decisions, if you can make a decision about where you want to drill hole number 2 and 3 off the basis of information you're getting from drill hole number 1, there's a whole bunch of ancillary effects that happen to our business around that change in those workflows. So there are changes to the way that shareholder value is created, changes in regulatory processes, business processes. But the really critical thing is there's a change in the way we manage change, and it's our people will have to operate at different timescales, and they'll have to operate with different information products than they are used to. And I think for this session and this forum, I think what I would like to see in the discussion is probably things like what are the skills, what skills will our geologists need in the future? So if we go from being an iHuman to an iGeologist, what does that iGeologist look like? So what are those skills? Do they need high-end numeric skills, mathematics skills, or do they just need an understanding of how that works? And actually it's about how they use the systems that will be more important. And I think one of the really key questions I have, because I look at how much time I spend just taking products to market, how much time I spend training. And, there's a good question about who will train these iGeologists. Do we want the universities to do the iGeology training, or do we want the universities just to train geoscience, and then the training for the I bit, the information bit, will happen somewhere else? Training providers, are these in the companies in-house? Are they external providers? Maybe, given where we are today, maybe these online training systems will be the way forward here. I think it's really important to identify in our company those innovators and early adopters. They are the way that we're going to pull the technology through. They need to pull the technology through, and the best ones, where it works and where you de-risk the introduction of technology the best, are when those innovators and early adopters are very, very good communicators and very, very good trainers again. So again, that training part of this whole equation becomes very prominent in everything we're doing. And I guess just that last point there is, look, we are in a strange place right now. This COVID-19 pandemic will leave us with better online systems down the track. And so I think this ability to train and how we do it is changing, and I think that's one of the things we need to think about as well.